In this lesson, we'll continue working with our previous example. Earlier, we used 9 observations found on Glassdoor to compute a confidence interval for the financial analyst salary. Here, we'll use the exact same sample mean and standard error, $92,533 and $4,644 respectively. However, let's change the number of sample observations from 9 to 25 and see what will happen. Everything else remains the same, and since we don't know the population variance, we will use student's t distribution to find the confidence interval. And here's the formula that allows us to find a confidence interval for the mean of a population with an unknown variance. All right, so we have the sample mean, standard deviation, and sample size. All we have to do is find the t-statistic. We will be able to obtain the t-statistic from the t-table. First, we need to specify the degrees of freedom. For our student's t-distribution, there are n-1 degrees of freedom. Our sample consists of 25 observations, so we have 24 degrees of freedom. Next, we need to find alpha divided by 2. We'll use the same confidence interval as the one used earlier, 95%. This means that alpha is equal to 5%. Therefore, half of alpha would be 2.5%. The associated t-statistic is around 2.06, which is lower than 2.31. And remember, the only thing that changed was the sample size used. We assumed that the standard error would remain for this example, although with a higher sample size it should go down. But let's keep it constant, please. We have all the information needed, so we just plug in the numbers. What we get is a confidence interval from $82,966 to $102,009. Let's compare this result to the one obtained earlier. When we had a sample size of 9 and not 25, we got a 95% confidence interval that was between $81,806 and $103,261. You can clearly note that the more observations we have in our sample, the narrower the confidence interval we can expect, because the t-statistic has a lower value.